Mr. Repke here, and we are going to start solving equations with radicals. So far we have been simplifying, adding, subtracting, multiplying, dividing radicals. Now we're going to solve equations that contain radicals. And we're going to go through 5 types of problems. You are taking notes along with me. Example 1, square root of 3x plus 7 equals 4. Now this should look very similar to problems that you've been solving since Algebra 1. I'll write it over to the right. You should know how to solve 3x plus 7 equals 4. The only thing new is that we have this square root. And anytime we solve equations, we're always doing the opposite. So if I want to get rid of this square root on the left side, I square both sides of the equation. Whatever I do to one side of the equation, I have to do to the other side of the equation. Well, if I square a square root, that just gets rid of the square root. So that just leaves me 3x plus 7 on the left side. On the right side, 4 squared is 16. And just like that, you see, this is very easy for us to solve. We subtract 7 from both sides. 3x equals 9. Divide both sides by 3. X equals 3. Easy enough. However, I will warn you, we do need to test these solutions. So we need to take the 3, plug it back into my original equation. So let's see. The square root of 3 times 3 plus 7. Well, that's the square root of 9 plus 7. That's the square root of 16. That seems like 4. And my original equation had a 4 on the right side. So this equation works. There is a chance that our answers do not work, so we must check our solutions. But the fact of how we got the x equals 3 should have been pretty easy. Let's try another one. Similar, example number 2. This time we're going to talk about a cubed root. We're going to do cubed root of 5x plus 2 equals negative 2. So you're thinking back to example 1 and you're saying, well, last time we squared both sides to get rid of the square root. Since this is a cubed root problem, we probably want to cube both sides. And let's do that. I'll cube the left side, and I'll cube the right side. On the left, 5x plus 2. On the right, negative 8. This looks like a simple Algebra 1 problem now. Subtract 2 from both sides. 5x equals negative 10. Divide by 5. Excuse me, that's a positive 5. And x equals negative 2. And again, we have our answer, x equals negative 2. Let's check it. So the cubed root of 5 times negative 2 plus 2. That's the cubed root of negative 10 plus 2. That's the cubed root of negative 8. Put that in your calculator, and we get negative 2. And a reminder on how to check a cubed root on our calculator. We're going to hit Math, the number 4. That brings up cubed root, and we would type in negative, make sure you're using negative next to the decimal point, 8, and hit enter, and that shows us negative 2. Since that's what was in our original problem, this works as a solution. Let's try another example. Example 3. Let's say 3 square roots of x minus 5 equals 7. Well, the first thing we want to do is isolate the x, just like we would do in a normal problem. So let me get that by itself by adding 5 to both sides. And I get 3 square roots of x equals 12. One way would be to take what we have right now and square both sides. That 3 squared is 9. Square root of x squared is just x. And 12 squared is 144. Divide both sides by 9. And x equals 16. I had to think there for a second. The other way is you could keep or continue to isolate the x, divide by 3, get a square root of x equals 4, and then squared both sides. Oh, look at that. Same answer. X equals 16. Doesn't matter which way you do it. Either way, we get the same answer. And again, we have to check our answer to make sure that it works. So I'll do that in the top here. 3 square roots of 16 minus 5 equals 7. That means 3 times 4 minus 5 equals 7. That's 12 minus 5 equals 7, and we know that. The 12 minus 5 does equal 7. So this answer works. X equals 16. Let's try example 4. This time we'll do a cubed root, but a very similar type of problem. 8 plus 4 cube roots of x equals 28. Isolate the x as we always want to do when we solve an equation. So I will subtract 8 from both sides. 4 cubed roots of x equals 20. I want smaller numbers, so I'll divide by 4 first. And that gives me the cubed root of x equals 5. Then I will cube both sides. X equals 125. Put that back into our original equation because we need to check all of our answers. 8 plus 4 times 5. 8 plus 20 is 28. So that means our answer works. Excellent. Let's up the difficulty a little bit. Example 5. Square root x minus 1 equals, this looks very similar to examples 1 and 2, but now on the right, I'm going to put an x minus 7. So now I have variables on the left and the right, and one of them is in a square root. So hopefully you think, well, on the left side we have a square root, we want to get rid of it, so we need to square both sides. And you would be absolutely correct in saying that. The left side, square root of x minus 1 squared, that's just x minus 1. Easy. But what did you get for the right side when you took x minus 7 and squared it? Did you remember to FOIL? I sure hope you did, because we would have to FOIL an x minus 7, because when it's squared, that means there's 2 of them. So first would be x squared, outer would be negative 7x, inner would be negative 7x, and last would be plus 49, because those 7s multiply. We can clean up the right side a little bit and make it x squared minus 14x plus 49. But how do we solve problems when we have an x squared? We did this last chapter with factoring. When it's an x squared, we solve by, what's our rule? So hopefully you're writing down FOIL in your notes to remember to FOIL. And if you don't remember how to solve this step, when we have an x squared, we want to set the equation equal to 0. So I will minus an x from both sides, and I will add a 1 to both sides. Now I get a 0, which I need when I have an x squared. x squared minus 15x plus 50 equals 0. So guess what this means? Oh, I know it. What we enjoy the most, we need to factor. Make your list for ways to multiply to 50 that add to 15. So my signs have to be the same. And they both have to be negative. And there it is, minus 5 and minus 10. So x minus 5 and x minus 10. So when we solve those, that's x is 5 and 10. But we have to check that. Does that work? And unfortunately, I ran out of space on this screen, so let me go to the next screen. So our problem was the square root of x minus 1 equals x minus 7. And our answers are 5 and 10. Let's try the 5. Does the square root of 5 minus 1 equal 5 minus 7? Is the square root of 4 equal to negative 2? Absolutely not. The square root of 4 is a positive 2, so that does not work. Let's try the 10. Does the square root of 10 minus 1 equal 10 minus 7? Is the square root of 9 equal to 3? Absolutely. So only x equals 10 is a solution, and that's why we need to check our solutions for all of these problems. Let's do another example just like that. Example 6. Square root of 5x plus 6 equals x plus 2. Well, again, the square root on the left side is the problem, so we square both sides. Left side is easy, 5x plus 6. The right side, we remember that there are two parentheses of x plus 2, which means FOIL. First, outer, inner, last. Combine the right side, and we get x squared plus 4x plus 4. How do we solve equations with an x squared? Absolutely, we should set this equal to 0. So I will minus the 5x and minus the 6, minus the 5x and minus the 6. And notice I line up my x's right there, and I line up my numbers right here. Hopefully that will help eliminate the possibility of mistakes. So 0 equals x squared minus x minus 2. By now we should see that that's going to factor to an x minus 2, x plus 1. So x equals 2 and negative 1. But, of course, we have to check that answer. So, x equals 2 or negative 1, and our original problem was 5x plus 6 equals x plus 2. I'll check the 2 first. Square root of 5 times 2 plus 6. That's the square root of 10 plus 6. That's the square root of 16 or 4. What do I get on the right side? 2 plus 2, and that's 4. So that one works. The 2 works. Let's try the negative 1. 5 times negative 1 plus 6 equals negative 1 plus 2. The square root of negative 5 plus 6, that's the square root of 1. And negative 1 plus 2 is 1. That works. So for this problem, both of our answers worked. X equals 2 and x equals negative 1. So in the 6 examples we've done so far, we only have one square root in our equations. Let's try an equation where there are two square roots in our equations. So the square root of 5x plus 3 equals the square root of 3x plus 7. And this should be pretty easy. Yeah, we got square roots on the left and the right, so let's square both sides. On the left, square roots go away. On the right, square roots go away. And this is just a basic solve problem. So I'll minus 3 from both sides. 5x equals 3x plus 4. I'll minus 3x from both sides. 2x equals 4. I'll divide both sides by 2. X equals 2. But I will check that answer. We always need to check. So I'll try to squeeze it in here. Square root of 5 times 2 plus 3 equals the square root of 3 times 2 plus 7. That's the square root of 10 plus 3 equals the square root of 6 plus 7. The square root of 13 equals the square root of 13. Absolutely. So that works. I don't have to know what the decimal is, but I just know that the square root of 13 equals the square root of 13. Let's try another one. And we're going to combine ideas on example 8. We're going to have two square roots, the square root of x plus 5 and the square root of x squared minus 15. So the initial part stays the same. Square both sides. So x plus 5 equals x squared minus 15. What's different between this problem and example 7? You notice we have an x squared. And you remember, how do we solve an equation when we have an x squared? We set it equal to 0. So let's minus x minus 5, minus x minus 5. So 0 equals x squared, my minus x minus 20. Make your list for negative 20. Remember, your larger column will be your negative. So 1 negative 20, 2 negative 10, 4 negative 5. Oh, that's the row that equals negative 1 when we add. So x plus 4, x minus 5 for our factoring. X equals negative 4 and 5. And we have to check. I'll go to another screen so we have enough space. So let's check our answers. We had x equals negative 4. Let me plug that in. So does negative 4 plus 5, the square root of that, equal the square root of negative 4 squared minus 15? That's asking, is the square root of 1 equal to the square root of 16 minus 15? Well, the square root of 1 equals the square root of 1. That seems to work. So check mark. Let's check 5. Does the square root of 5 plus 5 equal the square root of 5 squared minus 15? That's a 5 there, sorry. Is the square root of 10 equal the square root of 25 minus 15? Does the square root of 10 equal the square root of 10? Now, of course. So my x equals 5 works. So both of my original answers do work. X equals negative 4 and x equals 5. Let's try example 9. Square root x minus 3 plus the square root of x equals 3. So we have two square roots, but they're on opposite sides. So you might say, Mr. Repko, let's get those square roots to opposite sides, and we can do that. I'll minus square root of x from both sides. So that gives me square root of x minus 3 equals 3 minus the square root of x. Now you say, Mr. Repko, we have square roots, so let's square both sides. Good start. So we square the left. That's easy. X minus 3. And let's square the right. FOIL. Did you remember to FOIL? Because this means we have 3 minus square roots of x. The first is easy. 3 times 3 is 9. The outer, 3 times negative square root of x, well, that's minus 3 square roots of x. You know how to multiply with square roots. Our inner, negative square root of x times 3 is negative 3 square root of x. And our last, be careful here, negative square root of x times negative square root of x is positive. Negative times negative is positive. Square root of x times square root of x is just x. So now we have x minus 3 equals 9 minus 6 square roots of x plus x. And this should look sort of like examples 3 and 4. Let's get this square root of x by itself. I'll do that by minusing 9 from both sides and minusing x from both sides. And I'll write my answer up here on the right. X minus x actually cancels out. That's amazing. And negative 3 minus 9 is just negative 12. And what am I left with on the right? Just negative 6 square roots of x. Divide both sides by negative 6. So 2 equals the square root of x. Square both sides. X equals 4. So what we remembered was we got square roots on each side of the equal sign. I moved a square root, so I had a square root on each side of the equal sign here. One on the right, one on the left. Squared both sides. Remember to FOIL the right side. We got the square root of x by itself, and then it was just like examples 3 and 4. Last problem. Example 10. Square root of 4x minus 4 equals the square root of 2x minus 1 with a plus 1 that is not in the radical. Just like in problem 9, we are going to square both sides. Left side becomes 4x minus 4. Right side, we remember to write our parentheses a second time, and that should help us remember to FOIL. When I take the square root of 2x minus 1 times the square root of 2x minus 1, my first terms, I just get 2x minus 1. When I take 2x minus 1 times the 1 for my outer terms, I just get a square root of 2x minus 1. Same thing for my inner terms, and by now you should be noticing that your outer and inner terms are always the same. And my last term for FOIL, 1 times 1, is just 1. Let's simplify this a little bit. I have a minus 1 here and a plus 1 here. Those cancel out. And when I add square root of 2x minus 1 plus square root of 2x minus 1, that's just 2 square roots of 2x minus 1. Left side stays the same, 4x minus 4. Let's keep trying to solve this. We want to get this square root by itself, just like we did in examples 1, 2, 3, 4, and all of our other single radical problems. How would I get that by itself? Well, let's subtract 2x from both sides. That'll help. Now I have 2x minus 4 equals 2 square roots of 2x minus 1. Looking back at examples 3 and 4, can we see what we can do? Absolutely. Let's divide both sides by 2. How does that help me? Let's look at this 2x minus 4 over 2 right here on the left side and ask myself, can I reduce? Absolutely I can, because I can take a 2 into everything and just make that x minus 2 equals the square root of 2x minus 1. Now that we have a square root, we see we have to square both sides. On the right, I just get 2x minus 1. What happens on the left? Oh my gosh, we have to FOIL again, because I have another x minus 2. X squared minus 2x plus 4. Or x squared minus 4x plus 4 equals 2x minus 1. So this problem, unfortunately, is a double FOIL problem. Now we're back to, what do I do with an x squared in my equation? Well, I need to set that equal to 0. So since I need a little bit more space, let me go to a new page. So we have x squared minus 4x plus 4 equals 2x minus 1. Set it equal to 0, so subtract 2x from both sides and add 1 to both sides. That tells me x squared minus 6x plus 5 equals 0. How does that factor? That factors x minus 5, x minus 1, so x equals 5 and 1. Now that we're done with that, we have to test. I know, long problem. You will not have many like this, but we do need to know how to do them. Let's test the 5 first. 4 times 5 minus 4 equals the square root of 2 times 5 minus 1 plus 1. So that's saying the square root of 20 minus 4, which is the square root of 16, which is 4. And on the left side, that's the square root of 10 minus 1 plus 1, square root of 9 plus 1, 3 plus 1. Oh yeah, those equal. So my 5 works. Let's check the 1. Square root of 4 times 1 minus 4 equals the square root of 2 times 1 minus 1 plus 1. The square root of 4 minus 4, that's like the square root of 0. Let's see what we get on the right. The square root of 2 minus 1 plus 1. Or the square root of 1 plus 1. That's 2. The 0 equals 2, that doesn't seem like that works.